Okay, this is on M500-263, and it will discuss operation of the 224. This is a combination electronics package and control panel. There is no touch screen with the 224. This is sitting on a cart right now, but it will be up on a articulating arm mounted to the press. We assume that will be provided with the equipment. So one of the real nice things about the 224 is it powers up much more quickly than the 334. It's already powered up. It's ready to go. Perhaps the most confusing thing about operating the 224, why don't we start with that? And that is how to load and save jobs. Right now, you can see instead of calling them jobs in the 224, they're called presets. And there are 16, there are 16 presets. And the way it sort of works is if you're in preset 1, and then you go in and do some programming, change your sensor to crossover, change your sensor to die, those are sitting there in preset 1 almost as if they've been saved. And unless you save over them or change them, that's the way it's going to be in preset 1. Now, you can, let's say you know your job is saved in preset 1, but you want to create a new job in preset 1. So what you're going to do, what you want to do is save this job in preset 3. So I will go to the plus button, and now I'm in preset 3. And then I will press the down button one time, and it says copy from preset 1. Now I could change that. I could change it to copy from preset 2 or 3 or 4 all the way up to 16, but since the job is in preset 1, so what I did, once again, I went to preset 3 because that's where I want to save my job. Then I'm going to press the down arrow button once, and that will say copy from preset, and then you set the number that you want to copy from. And then you can see your copy button there. What I'm going to do is press and hold this paragraph button, and that will save the job in preset 1 to preset 3. Okay, and you saw it go capital and then back to lowercase, and that indicates that it took. So now, essentially, I have the same job in preset 1 and preset 3. Now let's say I wanted now to make some changes, and I wanted to make those in preset 1. I'm in preset 3. All I did was copy from 1 into 3, but I'm still set to 3. So if I went ahead and went down into the programming and started changing things, I'd actually be in preset 3, not preset 1. So I want to go back up, go to preset 1, and then I can go about reprogramming, and it will reside in that program. Okay, so that's the saving method used in the 224. In a way, it's simpler than current sort of Windows logic, but if you think about it, I think you'll see it's fairly intuitive. It's certainly straightforward, and there aren't too many button pushes required in order to do it. Okay, so as you saw, it powered up over here. It powers down over here. And once again, one of the nice things about it is how quick it is to power up. Okay, it's already ready to go. And it will come up in the preset that it was turned off. And let's say we go to 3 and we shut off, and then we turn back on. You can see that it opens back up in preset 3. Okay, you've already noticed some of the things that I'm doing with the buttons. Essentially the paragraphs and the screens on the 334 are contained in this little LED panel here. Changing numbers are done with the plus/minus buttons. Moving from one screen, you might say, to another, one paragraph to another, is done with this. It always boots up in the preset that it closed in. Then you go to the preset that you want, tapping the plus/minus buttons. Then you move on into the program. If you wanted to copy, this is when you would do it. We've already done that. We're going to stay in 1. One more down button push, and I enter the essentially the equivalent to the different screens on the 34. We've got feed mode, dimension base, pre-mark. Okay, I went down a few times there. Once I get into a paragraph, I need to get back to the paragraph heading in order to get out of the paragraph. So when I'm in reg mark, I'm looking at first mark offset, step up, reg mark type, quick window, contrast, reg mark gain, all the things that you're familiar with in the 34, and they do exactly the same thing, except this is different. The window size in the 24 is twice what this number is, so that means it's a 1-inch window, so it's plus/minus a ½ inch, whereas in the 34 you would put in you want a 1-inch window. So notice the plus/minus ½ inch, so you have a 1-inch window. You'll eventually work yourself back to the paragraph and press the paragraph button to move to press. You can continue over to punch, over to feed, over to die, over to batch, over to stats, and then you're back to pre-mark. So it's pre-mark, reg mark, press, punch, feed, die, batch, stats, and back to pre-mark. Okay, if we work our way down through the pre-mark, with your material, I think the simplest thing to do is just put in a 0 pre-mark position. We're running this in what's called paged coil, which is what you're laminating. And that's used when there's an irregular step up in the registration marks. You're basically going 2.55 for your step up, and then about 3.3 for your for the separation between the last mark on one page and the first mark on the next. And we're going to do all that with the first mark offset. So the pre-mark we're going to set to 0. If I set pre-mark position to 0, that means it's not going to use a pre-mark. And that means the only thing under the pre-mark paragraph is the pre-mark position. If I were to put in a number for the pre-mark, then additional data comes up. The type of the mark, the contrast of the mark, and the gain of the mark. But since and the window of the mark as well. But since, and do we want pre-mark correction? What that means is it will actually do a y-axis correction on the pre-mark, which is optional. You're not going to punch on the pre-mark, so you don't necessarily have to. But in this case, we're saying yes. We could also say no by plus-minus buttons. But since we're running with 0, none of that stuff is going to appear. The only thing is just that one bit of data on the pre-mark. We're saying 0. We're not going to use it. So we move to the reg mark, next paragraph, and we start to work our way down through the paragraph now. First mark, offset. It's set to 3 1/4. I think it's a little bit closer to 3.3, maybe 3.35. So we increase it a little bit. If you're a long way from where you want to be, you can double push these buttons. Let's say I wanted to go to 1 inch. I could go down slow by pushing the minus button, or I could go faster by adding a push of the plus button. So you can go up gradually with holding the button down, or one push at a time, or more quickly by holding first down the direction you want to go and then adding the other button to it. When you get close, hold down just the one button, and there we've got our first mark offset. Step up, 2.54. That looks pretty good. I measured it at 2.55, so 2.54 looks pretty good. I could make it 2.55. Mark type, this matches your mark. Angle line with the angle toward the back of the press. Again, moving down through the registration mark. Quick window, yes. What that means is as soon as the sensor has seen 4 edges, that is the 2 edges of the line and the 2 edges of the angle line, it will stop looking for any more marks. That helps to sometimes avoid getting bad mark signals back. The contrast, reg mark contrast, is dark. Could be light or dark. And the gain is auto. This one also can be put into manual. Did that by holding down the paragraph button, and that switched this from auto to manual. Looks like you were running yours in auto, and it looks like your reg marks are good quality, so probably the thing to do is just run in auto. And the window. ±5 is a big window, but that should be okay. Gives you a lot of room to find the mark. And that's it for reg mark. We've entered all the data for the reg mark. Next, we hit the paragraph button again, move over to press, work our way down through. We want the trip to be open. Alternately, you could have a delay, but you normally don't want to do that because it's slow. It tends to make you stop the press. So if at all possible, you always want to run with the trip open. Advanced delay also, turn that off. If you're having trouble with the web sticking on the anvil or something, sometimes delaying the advance helps a little bit. Normally not though. Usually just slows down production if you put a number in there. The duration that the conveyor is going to run to get your overlap the way you want it is controlled by 2 things. One is the air eject duration. If you set it to 1/100th of a second, it'll run for about 1/100th of a second. If you set it for 1/10, it'll run for 1/10 of a second. If you set it for a second, it'll run for a second. That's also influenced by the potentiometer on the back of the auxiliary power box, and the more clockwise, the longer it will run. Press stop, 220 over bottom dead center, BDC. I would say about 220 is what you want. I noticed that your off angle was quite large on the 334. I'm not sure why. If it's working for you, stick with it, but I think this is what we'd recommend for this press. Restart delay. Sometimes it's a good idea to have a little number in there. 0.3 of a second. That means if the press stops, it won't restart again for 0.3 of a second. And that can prevent certain confusions that might occur if you had it set to 0. And that's it for the press. Now we move over to the next paragraph, and that's punch. And first thing it asks is parts per repeat, which essentially means parts per sheet. And your printing is 4 parts up per sheet. So that way it'll know. It'll do 4 Regmark step-ups, 2.55, and then after that it'll know it's moving on to a new page, and it'll do the first mark offset of 3.35, I guess is where we set it. Okay, so 4 parts per sheet, 4 parts per repeat. And then bad parts to punch, same function as on the 334. If you happen to have a bad mark, it will go ahead and punch and keep going. You can set this to 0, or you can set it to go ahead and punch once and then stop, or don't accept any bad reg marks. If you get a single bad reg mark, it'll stop and won't punch. Here, if you get one, it'll punch once and then stop. Here, if you get one, it'll punch and keep going. Here, if you get 2 in a row, it'll punch 2 bad ones in a row and keep going. And 3 in a row and keep going. And 4 in a row and keep going. 5 in a row. I think this is the limit. Yeah. So typically, having 1 is good. It allows you to run faster for one thing. That's probably the most important reason for using it. Bad parts to skip. Normally that's set to 0, but use that if you wish. It does tend to make the web move more. You have to help it through the extractor, so you really don't want to skip a part. Parts eject sensor is off. That's more of a hard tool thing. Strip pullback is off. That needs to be off because if the feed tries to pull the web backwards when it's coil, which is what you're running, it will fault because the web won't go backwards because it's under tension. So you need to run with the strip pullback off. Dead man means you need to be holding down the foot switch in order to make the press run, and run pause means 1 push of the foot switch and it will just begin to run on its own, and it'll run if it gets more than 1 bad mark in a row. It'll stop, or if there's a feed fault it will stop, but otherwise it'll keep running. Feed. Working our way down through the feed paragraph. So we hit the paragraph button to get over to feed. Now we're going to scroll down through. Sensor to die. I'm not sure what that's going to be yet. We just have it arbitrarily set to a 1/2 inch. I'm sure you understand that perfectly well. It's the distance from the sensor to the registration mark when the part is in register under the die. So you're using this to correct the X position of the part in the die. Sensor to crossover, that's the distance between the angle and the line when the sheet is in the proper in-out position. That's probably going to be closer to, we haven't set it yet. That's kind of dependent on where you set your sensors and so forth, so I can't tell you exactly where it needs to be. But if you're right about the middle of the mark, which is where you want to be, it'll probably should be about that dimension, about 3/16, 0.185. Y out from stop. The correction range in y-axis is twice this number. We're putting it right in the middle of the range so you get your maximum in-out correction. You can go in 0.075 or out 0.075. Auto y-axis reset, that's for sheets, so that's turned off. Y out load, let's see, did I say that right? Yeah. Well, you know, actually, if you put it yes at the end of each sheet, it would go back to the home position for Y, which might actually make sense for you. You know, if the sheets are a little bit skewed, and one sheet is skewed and the other one isn't, if you have this set, it will go back to its nominal 0.075 position after it punches the fourth part on each page, which might be useful. Next is Y out to load. That is the one that's related to sheets, and so you never want to use that. Eject rate, this is another sheet one. It doesn't come into play. We could set it to 0 or anything. It's not used when you're running page coil. Feed rate, this one you do use. Okay, so the maximum rate of the material moving through the press will be 1 foot per second, 12 inches per second. That can go up to 24 inches per second. We really don't recommend running that fast. Say maybe 20 or 18 is the fastest you'd want to go. We'll set it for, while we're doing the machine setup, we'll set it to we'll leave it about 12. Okay, now we come to die. And the die button in coil doesn't have any settings. If we were in, for example, if we were in strip mode, the way we would get to strip mode is we go back, we reset with the green button. And switch from coil to strip. Work our way down, go back to the die, and then you have an option for a progressive die. And if you turn it on, then you have a knockout offset and pre-stations, as well as post-stations. But that's done only in strip mode or sheet mode. Okay, so let's go back. And to get back to the start, you have to reset. Go down, switch back to coil. And this only comes up after our reset. Once you get past this, the dimension base, once you get into the job setup screens, then in order to get back to those first few items, those first few selects, you have to reset. Batch is just like on your machine, your 334. Here we're saying no batch count. You could turn it on, and then the next down arrow push gives you your batch size, which can go up to 99 parts in a batch. and this keeps track of the batch count, and you can reset it with the paragraph button. Next is batch clear delay. Let's say if you had it set to 50 parts, when it got up to 50 parts, the press would stop and wait for 1 second before it resumed running. That's what that means. And stats, the last paragraph, we're almost back to pre-mark, is production rate, press count. This isn't a safe thing to keep track of your press count because it's pretty easy to reset. But for a particular job, you can use that to count press strokes. Press rate, this is something that gets auto set. It is the die switch, the operation of the die switch, and it has to cycle a few times with the press, and then this will figure out what the press rate is. You can change it ahead of time. Let's say you know it's going to be 30 strokes per minute. If the feed thinks that the press rate is 60 strokes per minute, you may end up, it may think it doesn't have time to move a part into position because this number is wrong. Whereas if you were really running at 30 strokes a minute, then there's twice as much time in effect to get the part into position. So it affects the feed's ability to think that it can run open. So if it's way off from where you know it is, you can set it before you actually start to run. This is a pretty typical number, 60, 90, 100 strokes per minute. Die switch closed. This is telling you the percentage of the total stroke that the die switch is closed. That is, this comes down, and at a certain point you can see that green light go out. That means the die switch is made. And so most of the stroke, the die set is going up and down, and what this is saying is that 16.7% of that total cycle, the die switch is closed. For a steel roll die job, that's a little bit low. You want that to be about 25%. And if this really is the number, we haven't run this yet, so I don't really know what it is. So I'm not going to readjust the die switch yet. But if it turned out to be that low, I would raise the die switch a little bit, which in effect increases the percentage of the cycle that the die switch will be closed. And that gives, what that really does is you can only move the web forward when the die switch is open. And if you try to move the web too soon, it can get caught on the die, or there won't be enough clearance to move the material, and that'll cause feed faults. So at any rate, on average, the best die switch close percentage for steel roll die jobs is about 25%. And that's it. The buttons along the bottom are, this is a language button. We have English and Spanish loaded. Just pushing that button switches the display from Spanish to English. This is a reset button. This is an advance button. This is an eject button, and that's non-operational in coil mode. This is a setup button, and this is the run button. This is a sense fault button. These two windows show you how close you are to the center of your correction range for the y-axis and for the x-axis. If the open space is near the edge, that means you're getting close to the limit of your y-axis correction. You want to have the gap a little closer to center, this would be okay. But if you're starting to get out, especially toward the outside two bars, then something's wrong. You may need to reposition the mechanical in out of the feed. This display shows the X position of the mark in the window as you're advancing along. So if the mark, let's say it's way over here, that indicates that you're near the sensing window. And you would adjust the step up in order, this would just be a single line. This is always the multiple line, and so the gap is showing you where you are in the range. And this one uses a single line to show you where the X mark is, where the line portion of the angle is relative to the sensor window. So you can fine-tune your step up as you watch this line and see where it is in the window.